Alrighty, here we go. Question 1. Diagram below, we're just trying to determine the sizes of these angles. Hopefully this is fairly straightforward. First up, we just put in what it says. So it says RPQ is 34. RPQ 34. And we put in our 90 degrees over here, because this PQR is a right angle. And determine the sizes. Now the thing is, for triangle RPQ, we've got two of the angles, we just need to get that third one. So it's just going to be 180 minus 34 minus 90. So it's 180 minus 124, so that'll get you 56. Gets this one up here, it's going to be 56. And we need to get PSQ, which is going to be this one at the top. And to do that, we should just be able to have a look and realize that we've got alternate angles in the same segment. So these two angles highlighted there are going to be the same. So one is always going, that one is also going to be 56. So that will be angle PSQ equals angle PRQ. And that's the same segment. And that is all that is needed for down here for part I. For part II, we're trying to figure out RPS. So I'm going to go a different color now. I'm going to go blue for this one. And that's RPS, which is this angle over here. Thing is, you should be able to see that angle, the triangle, PSR. Okay, so that's this triangle up here. That is an isosceles triangle, and therefore, because it's isosceles and we've got one of the angles already, 56, we can figure out the other. So triangle PSQ is isosceles, and therefore it's going to be 180 take 56 equals 2x. That'll be 124 equals 2x, x equals 62. So each of those angles down the bottom will be 62, and that's within the PSQ triangle. So that angle in there will be 62. This angle here will be 62. But obviously we only want this little one in here. Therefore it's going to end up being 62 minus 34. For that angle. So 62 minus 34 equals 28 degrees. So that's going to be the answer for that one. For part B, quite straightforward. If we have a look back to the angles in the same segment, the bow tie, so it's just points at the circumference and they cross over. That's what we've got. It's just slightly different sizes, but it's exactly the same thing. So this angle and this angle are the same. And then this angle are the same. And also these are vertically opposite. So any which way you end up getting, you end up saying that those three are the same. Obviously, as soon as you get to the same, the third will have to be the same. But I could write something down as which ones are the same. So yeah, you could literally, I'll make that a lot smaller. And then if I just type it in, I think it'll be a little bit easier. I'm just going to write the word angle. Angle EBC equals angle EAD, and then similarly for the other ones, angle BCE equals angle EDA. DA. And then lastly, angle BEC equals angle AED. That's because of vertically opposite. Okay. So fairly straightforward, that one should be pretty clear. So we can call that same segment, and lastly you will need a summary at the end. So something along the lines of both triangles, triangle BCE, I'll write it as per the question, BEC and triangle AED are similar due to angle. And that will be all you need for that one.